unique effect. Thank you very much. That's it.
Thank you very much. So the presentation is open for discussion. Is there any question, remarks? That's it.
So glucose transport is definitely a very important aspect of this. Did you look at hepatic glucose production as the final output of plasma glucose measurements?
What do you mean? But
well, in
liver cells, the gluconeogenesis, no, we
yeah.
haven't tested the glycolysis, we haven't checked.
Because if hepatic glucose production is also decreased, then you see a more efficacious control of blood glucose levels. So this is just one other aspect of continuing studying metabolism.
These animals, they were not starving. So, I mean, when we checked the blood glucose level, we couldn't, let's say, withdraw the food from this animal. Because without the food, it's very difficult to survive, this animal. So, this is why we kept the food there, and this is why I don't think that the gluconeogenesis or glycolysis is turned on in this system, because if they are hungry, let's eat. So if you do have a food, you're always congesting a food, you don't need this postprandial whatever mechanism is turned on. So relatively, the liver produced glucose mechanism, I think it's not a big deal, but I haven't tested.
Yeah, even in the fat state, about 30% of plasma glucose comes from hepatic glucose production, and it's net glucose production, meaning that glycerol contributes to restoring glucose levels. So it's kind of a fine regulation, yet I would definitely consider just looking at.
Could be.
It is when we make some any experiment according good laboratory practice or just experiment for ourselves, we should be sure that it is we change only one parameter, and it's if we compare water, here we not fix again oxygen 18 and oxygen 17, and it's if we see water with 135, if it's we got this water from the refinery column, it means oxygen is about oxygen 18, for example, it's 2000 ppm. And if for the 25 ppm of deuterium, it is oxygen 18, it is about 1600. It means different in oxygen, it's 400 ppm. And it could be that it is oxygen 18 or 17, act controversially with this, and it's so when we make some experiment, we have to be sure that it is we absolutely have absolutely the same water, and it's of course it could be like this, but to be sure, to be clear, we have to normalize water for the all parameter, not only with salinity and gas and temperature. Yes, it's just a comment.
Okay, I agree, but what we got, this deuterium depleted water, they already had, I think, some quality control, so they checked the deuterium content. I don't know whether they checked the isoform of the oxygen as well. I have no idea about it. So I only used the water, so I assume that that water was that they gave me.
When we take a sample of the water, take a sample.
Okay.
It means it's as usually it is we have to measure all the top, and refinery reduce three parameters. Yes, like this.
Okay.
Thank you.
Dr. George is going to say something. Say it.
when the deuterium is enriched almost to 100%, we produce reactor-grade heavy water. In that case, is the O18 level enriched 2 or 3 times more from the natural level, from the 2/10 of atom percent. That means if we change the 150 ppm to 135, then the O18 concentration change is negligible.
So finally, what we are saying that when we increased with 6,000 times the deuterium level from the natural level, that can increase it 2, 3, 4 the increase in the O18, and it means when we reduce from 150 ppm to 135, that can slightly modify the O18. So we do not believe that we really can, or we modify the composition of the water regarding the O18. So, and this is one thing we say, that we don't believe that the O18 can have a very important role in that process. The other, at the beginning of these experiments, we had carried out experiments when we use the deuterium depleted water and we add back the heavy water, and that way we got back the normal ppm for deuterium, and in that case we couldn't see any difference, saying that, so finally in that case the O18 we suppose was adjusted to the normal level. So this is the reason. I'm not sure, of course, the key issue what Jakub just said, that the modification of O18 could be very small comparing with the D concentration.
But if the absolute amount of the modification is higher than deuterium, because as I told it is, if we change deuterium for the 100 ppm, oxygen 18 changes for the 400 ppm.
Okay, I'm sure. Okay, we are very open for any kind of results which can say and compare different water molecules regarding the different oxygen isotopes.
Yes.
So
And
yeah, okay.
Okay, thank you.